Good evening, sir.
Good evening, sir.
Good evening, sir.
Evening, sir.
Everyone. Right. Good evening, people.
Good evening.
Yes, good evening. Let's continue with our chapter on postulates of quantum mechanics. That's the last, sorry, applications of quantum
Applications of
mechanics.
quantum mechanics.
Yes, that's the last chapter we have started. And yesterday we had started with 1D box. Do you guys have any questions in related to 1D box? You can ask right now. Whatever we have learned in quantum so far, if you have any questions, you can ask now. 1D box. Okay, so summarizing what we learned yesterday was that 1D box is basically of two types. Usually, I'm sorry, 1D box is only one, but it's a special case of infinite potential well box people. So in an infinite potential well, we take an unsymmetric box. Like this is y-axis and this is x-axis. You can create a box like this. This is known as a symmetric box, but we have taken an unsymmetric box people like this. Basically, on negative axis there is nothing, and all that we have is on positive axis. But the edges have got infinite potential. Here the potential goes to infinity. Here also the potential goes to infinity. Potential goes to infinity. So at x equals to 0 and at x equals to L, potential goes to infinity, and in between potential was 0. That is this is what is known as a 1D box, where potential is 0 only between x and L, and it becomes infinity at the boundary conditions. It becomes infinity at 0. It becomes infinity at L people. And then eventually we had found out that the wave function of any particle in a 1D box is given by under root of 2 by L sine n pi x by L. And the energy eigenvalue corresponding to this wave function En was found out to be n square pi square h square upon 2m L square if you want to by heart it in terms of h square, or you can also say n square h square upon 8m L square if you want to by heart it in terms of h. And importantly, n is actually principal quantum number here, 1, 2, 3, and it goes on. It does not start from 0. I explained that to you that y cannot start from 0, otherwise it will disobey the Heisenberg's uncertainty principle. So n is a principal quantum number, it starts from 1, 2, 3. This is a summarization of what we learned yesterday and what I needed today. Today's lecture is completely on 1D box, 2D box, and if time permits, then also 3D box. I'm taking it all together. People in no book whatsoever, they will teach 1D, 2D, 3D together. So they take potential after potential. They start with one this unsymmetric well potential, symmetric well potential, step potential, etc., etc. Then they go to 2D box. Eventually, they learn hydrogen atom, and they learn 3D box. But no, the best way to literally get a good hold in this box problem is if we learn all the boxes together. Similarly, I'll also teach you all the harmonic oscillators together. I'm not following the order of the book I'm still following, but I'm not following the order in which it is written. We'll take all the boxes together, 1D, 2D, 3D. We'll take all the harmonic oscillators together, 1D, 2D, 3D, and after that, we'll take the remaining potentials that we have been hearing about. Okay? I hope there's nothing to copy in this. If you're writing, still let me know. Okay, so next. So now I want us to plot the graph of this people. So if you remember, just like Rayleigh Jean had mentioned that wave function, we can compare it with stationary states. We can draw the wave function properly. If you realize, people, we have a stationary states wave function here. It's not. It's just a function of position. It's a sine wave function, and it's a function of n. You can have sine x, you can have sine 2x, you can have sine 3x. You can get all the different states. Every wave function can be represented by a different quantum number n people. So we can just plot a graph of wave function. For example, okay, don't copy. First, we'll just have a look. Okay, let's plot for n equals to 1, ground state, first level or ground state. So what is the wave function people? Psi n? Psi n is root of 2 by L sine n pi x by L, right? So right now I want to plot for psi 1 people. So this is root of 2 by L sine 1 pi x by L people. This is 0. This is L. This is x equals to 0. This is x equals to L. Now, first thing. So people, when x is 0, the value of psi becomes 0. When x is L, LL gets cancelled. What is sine pi? Sine pi becomes 0. Wave function again becomes 0. I hope you are with me. Substitute. Substitute x equals to 0. Substitute x equals to L. When x is L, LL gets cancelled. Sine pi is 0. When x is L by 2, here halfway. When x is L by 2, what happens? LL gets cancelled. What do you have? Sine pi by 2. Sine pi by 2 is sine 90. Sine 90 is what? This is the maximum value. Sine 90 reaches its maximum value, that is 1, and wave function is root of 2 by L. So you reach maximum potential there, people. You reach maximum potential at L by 2. So how does the graph look like? It looks like this, don't you think? This is it. This is how you represent the wave function in ground state. Ground state wave function is done. Next. Now let's study what happens at n equals to 2. I'm choosing this as reference. Okay? N equals to 2. Or wait, I'll just draw it a bit more.
Sir, I couldn't get you draw the curve from x equal to 0 to x equal to 12, but what it signifies?
Oh, pardon? X equals to 0 to x equals to 12, but?
You have drawn a curve, red colored curve.
What
it signifies? What it signifies?
Pardon?
What does it signify, sir? What does it mean? Why have you drawn a curve from x equal to 0 to 12?
It's a wave function. It's a sine wave function. Sine wave function.
Okay.
It's a wave
I
function.
mean, there is only a half wave, lambda by 2.
It's basically yes. So basically length of the wave right now. Like if you want to say, so if you want to define the wave function of this, the whole wave function from there, because this is node. Now we learned this is node. This is also node. Yes. It becomes maximum here. So we can define if you want. So let's say the corresponding wavelength right now. Suppose this is lambda 1. Okay. So obviously this is half wave. So you can say the wavelength is lambda 1, which is actually equals to. Sorry, I can say this is half wave. So this is lambda 1 by 2, half of wave. Right. So lambda 1 by 2 is equals to L. Lambda 1 by 2 is equals to L. So I can say lambda 1 is 2L. This is how we can find the wavelength corresponding to the wave function. Every wave function will have individual wavelength. Every wave function will have individual energy. This was the attempt that Rayleigh Jean tried to do to explain the black body radiation. He said that I can attach every wave function to a stationary state. All of them will have different wavelengths. All of them will have different corresponding energy eigenvalue. So that's what. So now we have what individual wavelength. If you want to first copy this, people do one thing. So copy this first. So this is the wavelength corresponding to the first wave. Okay, people. Let me finish writing.
No, sir. Sir, please wait a minute.
Take it.
Take a copy, I told you.
Take it.
First one.
Okay, no problem. Take it.
तो सर आप बोल रहे हो कि इस वेव फंक्शन का जो वेवलेंथ है, जो पॉसिबल वेवलेंथ है वो है ये 2L.
It has to be this, It has to be this.
Okay.
So right now we are drawing wave function, the psi of x versus x. And as of now I have drawn only ground state. Similarly, we can draw what happens for first excited state.
Yes, sir.
Others, let me try and Let's draw for first excited. Okay. Again, we are drawing psi of x versus the first excited state along x-axis. Okay. So now let's draw when n is 2, basically second level, and you can say first excited state. So the wave function psi2, this is root of 2 by L sine n by x by L. Now it becomes 2 pi x by L. Okay. Now maximum possibility is L. Don't forget, maximum possibility is L, and this is x equals to 0. This is x equals to L. So when x is 0, wave function is 0. When x is L, L gets cancelled. Sine 2 pi is again 0. Okay. When x is L by 2, let's check for half wave. Okay. When x is L by 2, L gets cancelled. 2 gets cancelled. Sine pi, this is still 0, people. So here also you are getting 0. Don't you think it should be something like this now? We can check. Basically, we are guessing at L by 4 it should be maximum now. See if you're getting maximum at L by 4 or not. If you're at L by 4, L gets cancelled. What are you getting? 2 pi by 4. What is 2 pi by 4? Pi by 2. Sine pi by 2 is maximum. Okay. So at L by 4 you are getting maximum. So I'm getting again at L by 2 I'm still getting 0 as you can see. But at L by 4 you are going to get maximum. Okay. And at 3L by 4 you will get maximum but in the opposite direction. Let's say. So this is how the wave function will look like. Okay. This is the wave function corresponding to second level or first excited state, people. Now you can say let's say the corresponding wavelength is lambda 2. But people, this time the whole wavelength is inside the box. Huh? Previously only half wave was inside the box. Now complete wave is inside the box. Lambda 2 is equals to L this time. Lambda 2 is equals to L. I hope this is understood. So this is for n equals to 2, second level, or you can say first excited state, people. So I think we can now, after this create a chain, we can guess what happens next. Half 1, 1.5, 2, 2.5, 3. Don't you think that should keep on repeating?
Yes, sir.
Yeah. This. Okay, yes. This. Tell me if you're right. Okay. So we can now just draw all of them once together. Okay. So let's say this is your half wave. The first, this is for n equals to 1. Then what happens at n equals to 2? At n equals to 2, we get one complete wave. Then what happens at n equals to 3? At n equals to 3, I'll get 1.5 wave, people. And then we can go on and on and on and on. Okay. This is it. So this is a ground state. Okay. Or you can say first level. This is first excited state. Or you can say second level. Energy from the wave function. Simple now. Suppose if I would give you only this graph, people. Suppose this graph. Okay. So if this is given to you, it tells you that n is 3. Then and there. Repeat. Suppose if I give you only this graph, it means you got n is 3 now. If n is 3, can't you calculate the energy? I can. What was energy formula for 1D? N square pi square h square upon 2ml square. So if I'm giving you that the graph looks like this, it automatically tells you that n is 3. You have to substitute. Answer would be what? 9 pi square h square upon 2ml square. They will give you mass, they will give you length, substitute, and you can find energy. So this is the significance of the graph. In one of the JAM paper itself, they have asked this question. I don't remember the year, but you can always check that out. Okay. So this is the graph of wave function versus position. Wave function versus position. I hope this is understood. Tell me if not. But important thing you need to understand is wave function is not at all defined. It is not defined at extremes. Wave function vanishes at extreme because potential reaches infinity at extremes. So please write it very clearly. The extreme points are excluded. The extreme points are excluded. We don't count them as nodes. The extreme points, we don't count the extreme points as nodes. Right now, we don't count the extreme points as nodes. You know the meaning of nodes and antinodes. No? Nodes means zero displacement, antinodes means maximum displacement. You know? So we don't count the extreme points as nodes because they're excluded. No? They're not a part of our graph, people, actually. Because at extremes, what happens? Wave functions it vanishes completely. Potential becomes infinity. Right?
So n equal to 2 for only one node.
Exactly, that's what I'm coming to. So basically, at n equals to 2, if they would ask you how many nodes are there, many students might end up telling me, so there are 3 nodes, but no, there are not 3 nodes. People, we don't include the extreme points. There is only one node here. Okay, so write it very clearly.
Sorry, n equal to 1. How many nodes?
0 nodes. There are no nodes. We just have one empty node. There is only one empty node, and there are no nodes. So write down now if you want. So basically, you can write for n equals to 1, we have got one empty node and 0 node. For n equals to 2, as you can see, I've got one node, but I've got one empty node here maximum, and I've got another empty node here maximum. So we have got one node and 2 empty nodes. We have got one node and 2 empty nodes. And you can create a chain here. If you have n equals to 3, as you can see, I don't have to include the extreme points. I've got one node, I've got one node. So there are 2 nodes. There are 2 nodes. But empty node maximum here, empty node maximum is here, empty node maximum is here. So we have got 3 empty nodes and 2 nodes. 3 empty nodes and 2 nodes. So basically, people, if n is p, what will be empty node?
P.
And what about nodes?
P minus.
P minus 1. N is 1, 1 node, 0 empty node. N is 2, 2 empty nodes, 1 node. And N is 3, 3 empty nodes, 2 nodes. 1, 0, 2, 1, 3, 2. Create a chain. Ask me if you have any questions. Don't hesitate. So if n is p, then empty node is also p. Node is p minus 1. We don't include the extreme points. Okay. We don't count them as nodes. In quantum, in your oscillation waves, you include them as nodes. There you include them. In quantum, we don't include them. Okay. Any questions? Anyone? Anyway, please ask. Shall we?
Yes, sir.
Okay. Next, one of the popular question is find the position of, let's say, wave function psi 2, psi 3, psi 5, anything where probability of finding the particle becomes maximum. I repeat, the question is usually find the position where probability of finding the particle becomes maximum. They will give you a wave function for psi 2, psi 3, psi 5, whatever. So basically, all you have to do is derivative process. No? You have to differentiate it with 0, and then you find maximum minima. Basically, it's maximum minima problem. Simple. Equate first derivative with 0, find the position, and then you can check whether it's maximum minima, whatever, using second derivative concept. However, there is a shortcut trick to get that answer in quantum. People, I hope you remember what is probability density in terms of psi?
Mod psi square
Perfect.
over the whole space.
Probability density is just small psi square.
Space.
Probability density, that is just small psi square. That's it. Nothing else. Okay. Now, when you say mod psi square, basically it means psi star psi, or you can also write psi star. But the point is, right now psi is real now in 1D box. In 1D box, psi is real. Psi is under root 2 by L sine n pi x by L. This is your psi n. So psi n star will also be same. Sin star will also be under root 2 by L sin n pi x by L. Okay. So what is sin into sin star? If you calculate probability density here, sin into sin star. So root of 2 by L into root of 2 by L, that's 2 by L. Sin n pi x into sin n pi x, that's sin square n pi x by L. Copy this. So this is a mod psi square, okay? Probability density. Are you aware of the graph of sine square? I think we may have discussed it. I'm not sure.
No, sir.
We have not discussed. Huh? Okay. Shall we?
Yes, sir.
So if you want to plot sine square, that's also very much identical to actually sine graph. But the difference is that this time you will have only positive values. Like for example, if you want to plot sine square theta, okay, so you can check what is the value for different theta. Suppose talk about theta, talk about sine square theta. So if theta is 0, sine 0 is 0. If theta is, let's say, pi by 4, sine pi by 4 is 1 upon root 2, 1 upon root 2 plus square, that's 1 by 2, which is 0.5. You can check for sine pi by 2, sine 90. Sine 90 is 1. Then again, after 90, you can check for
Sin 3 pi by 2.
we can directly jump. Pi by 4 is also not required. Sine 0, sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, but minus 1 square, it again becomes 1. Sine 2 pi again becomes 0, again 1. So you always have 0, 1, 0, 1, 0, 1, 0, 1 stack. We don't have 0, 1, 0, minus 1. So the graph is now like this, people. 0, 1, 0, 1, 0, 1, 0, 1.
Yes, sir.
It's always positive. Okay. So first, if you want to plot this, this is the graph of sine square theta versus theta. It's 0, then it's 1, it's 0. Okay, then 1 again, 0, 1 again. It goes on. So at pi by 2, we are getting 1. At pi, we are getting 0. At 3 pi by 2, we are getting 1. At 2 pi, we are getting 0, and it goes on.
Yes, sir.
Okay. And if suppose if you wouldn't have square, people, if you wouldn't have square, then the graph would be something like this. Huh? So the point is, the troughs have only become crest if you realize. When you square, the troughs only becomes whatever was a negative region, that only becomes a positive region. Nothing else, people. Nothing else. Because 0 to 2 pi is one wave, no? 0 to 2 pi is one wave, people. So if you wouldn't have square, if it was just a sine theta, then this would have been the graph. It means the troughs only becomes crest. So the point is, if I want to draw the graph of probability density, now we can directly jump on the result, people. Mod psi square, okay? If I want to draw the graph of probability density versus position, this is 0, this is L, infinite potential, okay? Then, just for your understanding, again, for ground state, if you take, suppose for n equals to 1, this will remain like this. That's not going to change, people. But if you talk about n equals to 2, second level or first excited state, people, the graph of wave function was like this. Huh? The graph of probability density would be 2 crests, something like this. I hope you have understood this. Tell me if not. This has to be the graph. This has to be the graph of probability density, people. Mod psi square for n equals to 2, because this is the graph for psi. Mod psi square only the graph becomes crest, people. Similarly, if you plot for n equals to 3, okay, the wave function was something like this, like 1, 2, 3. But now what you will have is you have 3 crests. No? You will have 3 crests, 1, 2, and 3. So the point is, in exam, if they ask you find the position where probability is becoming maximum, it means the density of probability should be maximum. Now, check the graph and write the answer. For example, for n equals to 1 people, where is the probability of finding it is maximum? L by 2. But for n equals to 2, the probability of finding maximum becomes at L by 4 and 3L by 4 people. Because n total is 0 to L. So this is L by 2, so this is L by 4 now, and this is 3L by 4. I hope you have understood this. Tell me if not. So these are the points where finding the probability becomes maximum. You can write here for n equals to 1, L by 2 is where finding probability is maximum. And similarly, here also you can say for this one, L by 4 and 3L by 4 is the reason, people. L by 4 and 3L by 4 is the reason where probability of finding the particle is maximum. And similarly, here also we can study this is 0, this is L. So this is L by 3, this is 2L by 3. 0, 1L by 3, 2L by 3, 3L by 3, which is L people. So this is what? L by 6. This must be 2L by 6. No, sorry. After L by 6, what do we have? Okay, 0, 1L by 6, 2L by 6, 3L by 6. This is L by 2. Okay, this is L by 2. And then 4L by 6, 5L by 6. This is 5L by 6. See how I am dividing this is L by 2. Okay, wait. How do I explain this? I understood this, but it's divided in 3 parts, now people. So this must be L by 3, and this must be 2L by 3. This becomes 3L by 3, which is L. 3L by 3, which is L actually. Okay. Now half of L by 3, that's L by 6. So it's like 0, 1L by 6, 2L by 6, which is L by 3, 3L by 6, which is L by 2, 4L by 6. Okay. Wait. I lost the track. 0, 1L by 6, 2L by 6, which is L by 3, 3L by 6, which is L by 2, 4L by 6, which is 2L by 3, 5L by 6, and then 6L by 6, which is L people. So the points where it becomes maximum is L by 6, L by 2, and 5L by 6 people. It becomes maximum at L by 6, L by 2, and 5L by 6. These are the positions where probability of finding the particle is maximum. I hope you understood this. Tell me honestly if not. It's okay. I can re-explain. Copy.
Can you please go through it?
Sure. Okay. So first of all, I tell you, have you understood the test crest idea?
Yes, sir. That's fine.
That's fine. So basically, in exam, we will ask you, these are the popular questions where they say, find the probability of finding a wave function psi 3 where it becomes maximum. Find the probability of finding the particle where it becomes maximum. It has a wave function, suppose psi 3. So how do we find it? Basically, you will have the equation of psi 3. Now you have psi 3 is under 2 by L, sin 3 by x by L. So if you want, you can differentiate this on both the sides, equate it with 0, take first derivative, second derivative, third derivative, whatever you want to do. Those process. So you can do that. Rather than that, I will plot the graph. This is the graph for the first, this is the graph for the second, this is the graph for the third. But probability density graphs. So probability density means what? It tells us how the probability is flowing. So where it is becoming maximum? It is becoming maximum here. It's becoming maximum at L by 2. Khatam. So for psi 1 case, probability becomes maximum at L by 2. Clear? Similarly, for psi 2 case, probability becomes maximum at L by 4 and 3L by 4. And similarly, for psi 3 case, probability becomes maximum at this position, this, and this. So I was only teaching how geometrically you find the positions. So for example, this is L by 2 first of all, half. This is half of L by 2, which is L by 4. So the point is, if you draw this, if you just draw 2 waves, 1 and 2, this is 0, this is L. So this is L by 2 now. This is half of L by 2, which is what actually L by 4. So how will I usually write the points? 0, 1L by 4, 2L by 4, 3L by 4, 4L by 4. This is how I write. 0, 1L by 4, 2L by 4, 3L by 4, 4L by 4. But the point is 2L by 4 means L by 2, yeah? And 4L by 4 means L. That is how you predict the positions quickly. This is L by 4 and 3L by 4 where it becomes maximum.
Okay, so now I got it.
And similarly, when we talk about three curves, okay, so this is 0, this is L first of all. Okay, so at center I have what L by 2. Okay, but what we can do is, instead of, okay, that's L by 2, that's fine. You have to divide L in 3 equal parts now. So it means it has to be L by 3, this has to be 2L by 3, and this becomes 3L by 3, which is L. 3L by 3, which is L. Now again, what is half this? What is the center of 0 and L by 3? L by 6, half of L by 6, this is L by 6. So how I will write usually? This is 0, 1L by 6, then 2L by 6, then 3L by 6, then 4L by 6, then 5L by 6, and then 6L by 6. Basically, it makes it L. As you can see, 6 gets cancelled. This is L. 3L by 6, which is L by 2, and 2L by 6, which is L by 3, 4L by 6, which is 12 by 3. But the point is, where it becomes maximum, it becomes maximum at L by 6, it becomes maximum at L by 2, it becomes maximum at 5L by 6. Clear? Everyone, please copy. Take your time. Don't hesitate, please. It's a scoring topic.
So probability maximum means we can get probability 1 at that point.
Yes. There's better noise.
Yes, sir.
Chalo, proceeding ahead. I hope you have copied this people. No, listen, wait, I think you said probability becomes 1 at that point. Not 1. The total probability is 1. At this point, you will have maximum. Like, for example, if you divide, so you can have 0.1, suppose 0.3, suppose 0.5, suppose 0.1, and 0.1. Sum of all is 1 now. Sum of these all right now, 0.5, 0.8, 0.9. Okay, this is crossing 1. So suppose right now, sum of all is 1 right now. 1, 2, 3, 4, check. 5, 8, 9, 10. But where is the maximum probability at the center? So we are not finding the value of the probability. We are finding the position where it becomes maximum. Clear?
Yes.
So it's not 1. It is maximum. So among all the distributions, among all the positions, we can say here it is highly probable. We don't know the value of that. We are just saying it is highly probable at this position. I'm glad you asked this question. People make a note. Maximum probability does not mean it is 1. It only means it is highest among the rest. It is highest among the rest. Okay, that is the meaning of maximum probability. Because you can never have probability as 1 at a fixed point. It means you're violating Heisenberg uncertainty. You're telling me with surety that I will get the particle here. That's insane. I can never tell that. Okay. We can only say it is 50% probable that the particle will be here. It's 70% probable that the particle will be here. We can never say with 100% surety that the particle will be here. We can never say that. We can say that it will be here in a region like 0 to L. It will 100% be there. But at a specific point, you cannot say that it will be here. At one point, you cannot say that. Okay. Good that you asked that. Okay, people. Chalo, next. Now, also remember, just in case they give you a wave function, let's say a wave function of a particle was linear combination, like in 1D box. It was linear combination of, let's say, C1 psi1 plus C2 psi 3 or C3 psi 3. First of all, how do we write this? C1 into psi1 means root of 2 by L sine 1 pi x by L. Okay, and C3 psi 3 means what, people? Root of 2 by L sine 3 pi x by L. Just n pi x by L you have to take care. So 1 will have 1 here, 3 will have 3 here. This is how we write the wave function. That's understood. Okay. Now, if they ask you to write this equation in time evolution format, what will be the same equation after some time? Can you tell me what we are supposed to do? This is initially. How should I write this equation at x comma t?
Sir, e raised to minus it by 2h.
Basically, you're close. You understood what you're supposed to do, but yes, you don't remember.
Yes, yes,
That's it. पता था क्या करना है बस याद नहीं था कि क्या तो चीज
सर वो क्लियर याद नहीं आ रहा
No
सर.
problem. E raised to minus it upon h cut into E1 in the first case. Energy eigenvalue E1. Okay. Even I'm not sure now.
Yes sir, yes sir.
This is correct. Okay. And then similarly, we have C2 under root of 2 by L sine 3 pi x by L. Okay. E raised to minus it upon h cut E3 people. Okay. So depending upon the quantum number, you have to write. You just have to multiply with e raised to minus it upon h cut En respectively. Okay. So basically, you can say the total wave function is sum of Ci psi I initially. This is at t equals to 0. But if you want to find the value of wave function at some time t, then this is Ci psi I e raised to minus it upon h cut into E5. I hope this is understood. Tell me if not. So respective the quantum number you have to multiply. For psi1 you will multiply E1 here. For psi3 you will write E3 here. Let me know if you have any questions. Don't hesitate. Shall we?
No sir, 1 minute.
Take your time.
Okay sir.
Others also let me make a writing. Okay. Next. Let's take a question here. So before I take question, I need you to recall Pauli's exclusion principle, people. Pauli's exclusion principle. Okay. It just tells us that no more than 2 fermions. No more than 2 fermions. Mostly we will deal with electrons, people. Okay. No more than 2 fermions can be in the same excited state. Can be in the same state. Can be in the same state. Basically, in one particular energy state, people, in one particular energy level, at maximum we can have only 2 electrons. In one state, we can have at maximum only 2 electrons or protons. Protons are also fermions. Okay, protons are also fermions. I will do one thing. After we complete the syllabus, maybe if time permits, on one day we can take one lecture on elementary particle physics, where we can just discuss standard model, where fermions and then hadrons, bosons, and quarks and everything. Basically, all of that standard model. It won't be a compulsory class to attend. We can discuss about it. It's good for just. It's very important for this. For Jam, it's fine.
Sir, you can take it on Friday. I mean tomorrow.
Friday. Tomorrow to let's see. But let's see. And I don't want to basically disrupt the flow of the class. First, we'll complete this level, then we can decide about taking that.
So in the same state, मतलब ये कि दो identical fermions,
Well,
identical nature.
you will understand as we go. Hang on. Okay. And by the way, electrons and fermions, they are always identical. Nothing like
Yes, sir.
they are
कुछ ना कुछ तो फर्क होगा.
The फर्क is only in the spins, and hence you say no more than 2. If there's spinless fermion, then they are anyway identical. So the point is, suppose if I give an energy state E1, okay, at maximum you can have 2 electrons, and that too because one will have upspin, other will have downspin. If you talk about energy state E2, at maximum I can have 2 electrons, one will be up, other will be down. Both the electrons cannot even have same spin. That also you can note if you want. Even the 2 electrons, even the 2 fermions that will be there in the same state, they cannot have same spin. That's also important. In fact, the two fermions in the same state, cannot have same spin. Cannot have same spin. So one must be upspin, other must be downspin. And apart from that, they are completely identical. Everything. The two fermions in the same state, they cannot have same spin. Okay. Sure. Next. Proceeding, right? Let's take a question. People hear onwards the important kind of questions, which are 100% expected in exam from this chapter starts. Basically, these kind of questions. There has to be one question out of 1D, 2D, 3D box. There has to be one question out of 1D, 2D, 3D harmonic oscillator. These two are the most popular topics, and the kind of questions that we are going to do now are the kind of questions we can expect in the paper. So to start with, suppose if I give you 3 fermions are present in a 1D box. In a 1D box, and I'm asking you the minimum possible energy of the system. The minimum possible energy of the system is. Okay? And there are 4 options given to you. So let's discuss. So first of all, it's a 1D box. I can have n equals to 1.
So,
You can have. Pardon?
please wait. First we want to copy the question. Please wait.
That's okay. Take the step. You want to copy the question?
Yeah, exactly. After that.
3 fermions are present in a 1D box. The minimum possible energy of the system is.
सर हमें n कितना पता है? मतलब how many n's are there?
N could be infinite, but the important word is minimum.
Okay.
The important word is minimum. So you have to start from ground. You have to start from lowest.
2 fermions in one state and 1 in another state.
Exactly. That's it. And that is the importance of the word minimum. Because like you got confused, sir, n is not given to us. Obviously, they're not given us because they're talking about minimum. You can keep on writing n equals to 1, n equals to 2, n equals to 3. It doesn't matter. But minimum means you have to start from ground. But at one time, I can maximum have 2 electrons. I can have 2 fermions. I cannot have the third fermion. So third has to go here. We don't care about the spin. The third one can have upspin. The third one can have downspin. We don't care about the spin of the third. Okay? But the point is, the third one will go in the second state. That's it. So what is the energy of the system? So we have got 2 electrons in the ground state, and we have got 1 electron in the first excited state. Clear, people? 2 electrons have got E1 energy, 1 electron has got E2 energy, because we cannot have third electron here. Okay? So this is 2 into E1, which is what is the energy? N square pi square h square upon 2 ml square. Okay? So 1 square pi square h square upon 2 ml square plus E2, which is 2 square pi square h square upon 2 ml square E2. I'm using the formula. Tell me if you have any confusion. So this is 2 pi square h square upon 2 ml square plus this is 4 pi square h square upon 2 ml square. Our answer is 2 plus 4 is 6. 6 upon 2 is 3. Answer is 3 pi square h square upon ml square. This will be one of the options. I hope you understood this. Tell me if not.
So that's why more than 2 electrons are not allowed in our orbital. No? That's
Yes. And both of them will have opposite spin also.
So I didn't get that last part. Why is that orbitals? The orbital. You said something about orbitals, right?
Orbital. No, so orbital. There's a 2 maximum 2 of electron can be in an orbital. That is not orbital. Orbit can.
SPDF, no?
Yeah, exactly.
Yes. But
What was the reason behind it?
Pauli's exclusion principle only.
Okay. Yeah,
So yes. So basically that is connected to that. Next. And I was saying, so I can reframe this question people in a way. Right now this is an MCQ. I can convert this in an NAD. Like is dash times E1. Okay. So what you can do is you can calculate total energy system and divide it with E1 now. So for example, energy of system upon energy of E1. So what is energy of system? 3 pi square h square upon ml square. Okay. Or you could have kept it 6 upon 2 ml square because you know, right? 2 will get cancelled eventually if you realize. So this is 6 pi square h square upon 2 ml square actually. Correct? 4 plus 2 is 6 and upon 2. And what is E1? Just E1. 1 square pi square h square upon 2 ml square. 1 square pi square h square upon 2 ml square. This is energy of first level. Okay. So as we see, pi square h square upon 2 ml square is cancelled. Pi square h square upon 2 ml square is cancelled. We get 6. So you can say energy of system is 6 times E1 to 2. Tell me if you have any questions. Energy of system is 6 times E1.
सर
बोलो।
मिनिमम के जगह अगर मैक्सिमम दिया होगा तो n equals to 3 होगा ना?
नहीं मैक्सिमम तो
Maximum तो infinity तक पहुंचा।
हाँ वो तो I mean they have to tell us what is the upper boundary in that case. This is me who have gone in equals to 3. You can draw n equals to 4, n equals to 5, whatever. And if they mention to give you upper boundary, I think
Okay.
just a second. So if they mention upper boundary, if I've given you suppose that 3 orbits are possible, and now if I tell you what is the maximum possible energy, then you can say 2 is up and 1 is down. Here. So 2 will be in the third state and 1 will be in the second state. Okay, but this is logically not possible. I mean,
Yes, sir.
but for
No,
creating a
also
question,
clear.
but for creating a question, we can create a question. But logically, physically, that's not. What is the importance of minimum possible energy, people? Every particle, like any configuration that is made in the universe, everything tries to, succumb itself into a state where they can share minimum possible energy. Everybody wants stability, basically. Okay? You can have good stability if you have got less energy. So everybody wants to achieve minimum energy. So that's there. But okay. So next. Now, interestingly, suppose if in the same question, instead of fermions, if I would make it bosons, people. Okay, 3 bosons. Same question. 1D box. Okay, and they're asking you minimum energy. 3 bosons, 1D box, and minimum energy. The thing is, people, Pauli's exclusion principle is valid only for fermions. Huh? So when
Yes,
you
sir.
say
वो
bosons,
एक तीनों एक ही में चले जाएंगे.
all of them can be now in the ground state. खत्म. When they say bosons, Pauli's is not valid on this. All of them will be in the ground state. Okay. So energy, you can simply say all of them will be in the ground state. That's it. 3 even directly. You can write PEP is not valid on bosons. Okay. Pauli's exclusion principle is not valid on bosons. Okay. So if they mention that all of them, so if they mention find the minimum energy, it means all of them must be in the ground state. Huh? All of them must be in the ground state. Therefore, for minimum energy, all will be in ground. Of course, you can write any number of bosons can be in excited state. Okay. Any number of bosons can share the same state. Can share the same state. And because they have mentioned minimum energy, it means all are in the ground state. All are in the ground state. Okay. So answer would be just 3 times E1 people. So this is 3 into 1 square pi square h square upon 2 ml square. So that is just pi square h square upon 2 ml square multiplied by 3. Clear people?
Yes, sir.
सर प्रीवियस स्लाइड पर दिखाएंगे.
Sure.
सर इसमें E1 जो 2 है ना 2 E1 है तो उसमें 2 मल्टीप्लाई नहीं होगा.
नहीं. This is in terms of energy E1. Like E1 तो उतना ही ना. You're not calculating the total E1 in terms of the total E1. This is just in terms of E1. E1 is this. Have a look. We are not
Yes, sir.
approaching E1.
Yes,
So
sir.
only 1 pi square.
Okay, sir.
No problem. ठीक है. Done people? Shall we?
Yes, sir.
Next. Take your time. Okay. Now again in the same question, if I would make it 3 spinless fermions. People. Suppose due to some anomaly, whatever, the spins of the fermions are destroyed, but they are fermions, but the spins are destroyed. Then what will be the minimum energy?
सर तो वो बोसन
एक में आ
हो
जाएगा.
जाएगा ना. एक
एक
में.
में आ जाएगा.
Nah.
फर्स्ट फॉर्म में नहीं डाले बस वो वैसे बस ही रहेगा 2E1 और 1N1 में.
सर E1 plus E2 plus E3.
Perfect.
So
E1 plus E2
that's-
plus E3. Because it is fermion, Pauli's exclusion principle is still valid. Okay. Since Pauli's exclusion principle is still valid because it's fermion, so no more than 2 can be in the same state. But the point is, since they does not have any spin right now, so just draw dots. 1 is here. Now second cannot be here because first of all they don't have any spins. Okay. Or you can say that they have got same. It will be saying like they have got same spins, or it will be saying like they have got opposite spins. Whatever. The point is now they become completely identical, and 2 identical fermions cannot be in the same state. To be more precise, when I told you here that in fact the 2 fermions in the same state cannot have same spin, basically they cannot be identical. And add this. When you said that the 2 fermions in the same state cannot have same spin, it means just write down. It means they cannot be identical. So if they don't have any spin, it means all of them are identical. Right? If none of them have any spin, it means all of them are identical. And if all of them are identical, I cannot have both of them in the same state. So I will have 1 electron here, other has to go here, other has to go here. There is no other option. There is no other option. 2 electrons now cannot, because if both are in the same state, it means they are identical. You are disobeying Pauli's exclusion principle. 2 electrons could be in the same state provided that they had opposite spins. But now since both of them don't have opposite spins, since they are not since they are identical people, all of them must be in the different states now. So minimum energy would be E1 plus E2 plus E3. One is in E1, other is in E2, other is in E3 people. I hope you understood this. Tell me if not.
Yes, sir. समझ गए.
Okay. See, these are some creative questions I'm just putting. I will just love if they ask these questions. Like not only on fermions, they should ask on bosons and on spinless fermions. But the thing is, students may not be aware of the standard model, so they will have to use the word bosons and fermions. Otherwise, more interesting would be I would have mentioned, for example, that suppose 3 God particles. God particles are nothing but by the way bosons. Okay, are used. So first students need to know okay, what are God particles? Like are they in fermions or are they in bosons? So if I use 3 neutrinos, so where does neutrino fall? Do they fall in fermions or do they fall in bosons? But I think they won't do that because standard model is not written in JAM syllabus exclusively anyway. So anyway, so this is E1, which is by the way, what is En? En is n square pi square h square square upon 2 ml square. No? Can we directly write it n square E1? Shortcut now. Because what is E1? E1 is just pi square h square upon 2 ml square. No? What is E1? 1 square pi square h square upon 2 ml square. Take ratio. What do you have? En upon E1. This is pi square h square upon 2 ml square gets cancelled. Pi square h square upon 2 ml square gets cancelled. This is n square upon 1. So you can directly remember En is n square times E1. Best now. So that we can save some time. E1 would be E1. E2 would be 2 square E1. And E3 would be 3 square E1. But perfect. Time saving sir. So E1 plus 4 E1 plus 9 E1. So this is 9 plus 4, 13, 13 plus 1, 14. 14 E1 is the answer. Clear people? Tell me if not, please.
Yes, sir.
Good. Okay. Next. And remember, in the formula, when you write n square pi square h square upon 2 ml square, L is the length of the 1D box, n is the quantum number, pi is constant, h is constant, m is what? M is the mass of the fermion. Write it clearly. M is mass of fermion. Whatever fermion you are using, electron to electron, proton to proton. M is mass of fermion. Don't write fermion, basically mass of, it could be bosons also. Mass of particles, mention mass of particles. Don't mention fermion, it could be bosons also. So mass of particles. So next, proceeding ahead. Now suppose I have given you that we have got 5 particles, out of which 3 are electrons and 2 are protons, and 1D box, and I want us to find minimum energy. And they have given us that ground state of corresponding to electron, ground state energy corresponding to electron is E1, and ground state energy corresponding to proton is E1 dash. Okay, I want to use some other notation. E1, En, we can use maybe. Okay, I think we'll have to go with E1 and E1 dash. But let's just write EE and E. Better. There are 5 particles, out of which 3 are electrons and 2 are protons. 1D box, minimum energy we want to find. They have given us ground state energy corresponding to electron is EE, and ground state energy corresponding to proton is EP. Why do they have first of all different ground state energy?
Both on fermion.
Both are fermions. Protons, electrons, both are fermions.
Different mass.
Different mass. That's and hence I give you that note right now because energy depends on mass. Right? Mass is different, energy is different. Yeah. Obviously, they will have different energy, right? They both have different ground state energy because they both have different mass. They both have different ground state energy because they both have different mass. Because in this, many students make a common mistake. If they have not learned this exclusively, many students think there are 5 particles. They will say 2 in the ground state, 2 in the first state, and 1 in this, and they'll end up writing 2e1 plus 2e2 plus 1e3. That's wrong. Now you are saying that they both share same energy. People have to draw different diagrams for electrons. You have to draw different diagrams for protons because their energies are also different. Their energies are different. You cannot. It's a 5 electron problem. People. It's a 5 particle problem with 3 electrons and 2 protons. Okay. So the answer, you have to draw 2 different diagrams, one for electron and one for proton, because their energies are different. People. Simple. Their energies are different. So this is electron, this is proton, and you can say there are 3 electrons, correct? So 2 electrons will be in the ground state, 1 will be in the first excited state, and there are 2 protons, correct? So both the protons will be in the ground state. I hope you understood this. Tell me if not. Because they have different energy. You cannot draw them in the same diagram. Copy this. So what is energy, people? Here energy of ground state is E, and what is the energy here? Here energy of the ground state is given EP. What is this energy then?
4e.
4e. That's it, no? Because we wrote the n square times e people here, n square times ground state. Okay, this is n equals to 2. I hope you are catching this up. N equals to 2, you can write n square e. So this is 4e. So answer, energy of system would be you have 2 electrons in the ground state, you have 1 electrons in the 4 into e state, and you have 2 protons in the EP state. People. 2 electrons are there with energy e, 1 electron has energy 4e, and 2 protons have energy ep. People. So your answer is basically 6 times electronic energy plus 2 times protonic energy. I hope you understood this one. This is as hard as it can get. Nothing beyond this they can go for 1D. Maximum level in 1D. Okay. Nothing beyond this they can even think of asking. I tried to cover everything. Tell me if you have any questions, please.
Sir, I don't understand physics.
Sure. So if suppose if an exam I have given you, I've got 5 electrons. Okay. So you know the answer already. N equals to 1, you will say n equals to 2, you will say n equals to 3. 5 electrons. So you will end up telling me 2 electrons are in the ground state, next 2 electrons are in the first excited state, and the 5th electron is in the third. So answer, what is the energy of system right now? 2 are in the ground state, then 2 are in the second level, and 1 electron is in the third level. So this is 2e1 plus 2 into what is energy? N square e1. We learned shortcut n square e1. So this is 2 square e1 plus 1 into this is 3 square e1. I hope you have with me. Tell me now.
Yes, sir.
So this is 2
नहीं सर, वो ग्राउंड में
हाँ
ग्राउंड में कैसे मतलब 4 हो जाएगा ना, इलेक्ट्रॉन 2 प्रोटॉन 2 हो जाएगा उसमें वो नहीं होना चाहिए.
I'm coming to that. So basically this is 2 square, this is 4, 4 2s are 8, e1 plus 3 square, this is 9, this is 9 e1, 9 17 19. So first of all, this is 19 e1, this is understood.
Yes, yes.
Now go back to this. See, the thing is, energy of electron is different. Q n square pi square h square square upon 2 ml square. Mass of electron is different now. And energy of proton is different. N square pi square h square upon 2 ml square. Mass of proton is different. So this energy, ground state energy, and this ground state energy are not same ground state energy. This is mass of electron and this is mass of proton. Both are different ground state energies. So obviously, likewise,
Okay,
we have got different
Okay.
excited state energy. Okay. So you have to treat electrons separately and you have to treat protons separately.
Yes, sir. Yes, sir. Thank you, sir. Okay.
No problem. Others also you can ask me. Hello? Noise, complete noise. I cannot hear you at all. Too much of noise, bolo. Try. No, still noise, complete noise. Try texting in the chat box.
Sir, mass of electron, mass of proton related है ना, तो हम समझ सकते हैं.
हाँ, मतलब if you want, you can always do that. But that way, actually, to be honest, electronic energy would be very large. Protonic energy is negligible because mass of proton is 1,836 times mass of electron. So this energy becomes negligible actually, comparatively to electronic energy. So that way, you can always find the relationship. That's fine. You can write if you want. Mass of proton is equal to 1836 times mass of electron. Because of which the energy of proton will be very much less than energy of electron because energy is inversely proportional to mass. So protonic energy is actually very much negligible. Actually, it will be a good task now. I would just give 5-6 protons and 3-4 electrons, and I would ask which of the following options are approximately correct. And proton answer is right option. Students need to focus on the word approximately because protonic energy have to ignore now. Nice. I hope you understood what I'm trying to say here.
उसका ग्राउंड स्टेट एनर्जी नहीं रहेगा, आप बोलना चाहते हो.
नहीं रहेगा, but it will be very negligible ना.
हाँ, तो इसे हम इग्नोर कर सकते हैं.
So we have to ignore comparatively to electrons. Like electron will be, suppose if it's 5 electron volt, this will end up having 0.002 or 0.003 electron volt. You're going to divide it by 1836. So it will be very negligible comparatively to 5. And hence I will use the word in the question that which of the following options are approximately correct. That would be more fun. Nice. Done, people. Okay. Chalo. So now I'm confused a bit. We are done with 1D and we have 19 minutes. We can start with 2D, but I'm not sure if we'll be able to complete 2D. Chalo karte hain. Direct analogy. Please divide in 2D box. I hope all of you understood 1D completely. If you have any hesitation in any of the problems, you can ask me now. Let's see. Chalo. So first of all, people, wave function in your BSc derivation, you must have learned that you can split the wave function in 2 parts. Like if suppose it's a function of x comma t, then you can say, let's say it's function of f of x into f of t. Like they can be explicitly splitted. For example, if you have learned psi of r theta phi, I'm sure you have learned something like you can split this as r into r, theta into theta, and phi into phi. But the point is, whatever are the coordinates, you can explicitly split them. This is valid in wave function. If you are thinking, sir, how exactly? Well, it will depend what kind of a function they have given you. So, for example, suppose if I would give you, let's say, wave function is e raised to this thing, r plus theta. This is for an idea. So we can split this now. This is e raised to r into e raised to theta. Right now it's a function of r and theta, but now it's r is separate and theta is separate. So wave function is always splittable. Wave function is always splittable. That's the first thing I want you to note. So not in x time coordinate, not in x time coordinate. I want you to note that if I have a wave function x comma y, okay, we are allowed to split this s f1x into f2y. Make a note. Something in the chat box. So yes, sir, completely for the first time. Nice. So we can split the wave function. So in 2D, basically, people, what do we have? I'll tell you one thing. This whole 1D that we learned, that was along x-axis. Similarly, you can develop a whole theory of 1D along y-axis. Nothing will change. Just you have to replace x with y. For example, wave function was root of 2 by L sin n pi x by L. What you will write there? Root of 2 by L sin n pi y by L.
Why by?
Okay. So you can develop the whole theory for 1D along y-axis also. Everything, even energy will remain same. Energy will be n square pi square x square upon 2ml square. Nothing will change. Just the wave function, when you write it, it would become root of 2 by L sin n pi y by L. That will be the only change. Okay. So the point is that when we're talking about 2D, it means now I have two coordinates x and y. And just like I said, we're allowed to split it into two parts, psi1x into psi2 y. And we already know the wave function, people. This is basically wave function of 1D along x-axis. This is wave function of 1D along y-axis. If you multiply them, we get wave function of 2D, people. Now what is wave function of 1D? Root of 2 by L sin n pi x by L. Don't copy. I need to teach you something to this. Root of 2 by L sin n pi y by L. The thing is, this is how most of the books will write. And I think related to this, probably they will ask you questions in Java also. But who told you that this box is a square? What if it's a rectangular box? The meaning, what if length along x-axis and y-axis is different? That could be a possibility. No? So in that case, you just have to ensure you write Lx here, length along x-axis, here also length along x-axis, here length along y-axis, and here you have length along y-axis. I'm giving you a general case, people. We can take a special case later. So this is right now I can call this a rectangular 2D box. Okay. Now, and also, who told you that the quantum numbers will be equal? I can have along x-axis, I can have first, I can have nx is 1. Along y-axis, I can have ny is 3. I can have anything. So the point is, even quantum numbers cannot be same. Not necessarily they will be same. So we can use nx, ny, people. So the point is, first let's write the general quantum. Root of 2 by L sin n pi x by L. That's fine. That's fine. But what I'm going to do is, I'll write it as Lx, nx, and lx, creating a general quantum. Okay. And then similarly, we can have root of 2 by L sin n pi y by L. But I will add ly, ny, and ly. Okay. And remember, back then you used to express wave function as psi n. Now how should I express this? This will be psi nx, ny. I'm sure in hydrogen atoms chapter earlier in your BSc you must have seen something like psi 100, psi 210, whatever. People, that is actually quantum numbers nx, ly, and z. Or if it's hydrogen atom, then you write NLM. So n is principal quantum, L is that angular quantum, m is magnetic quantum. But the point is, those numbers that you have below the wave function, those are nothing but the quantum numbers. So here you can write psi nx and y. So basically we can have now psi 10, we can have psi 01, we can have psi 11, we can have psi 21, we can have anything. That's what I'm trying to say. However, we won't have 0. Nx and ny again cannot be 0 values. The condition still remains as it is. I hope first you understood the wave function, people. Copy. This is, you can call this a rectangular. This is wave function for rectangular 1D box. Take your time. And by the way, energy is scalar. So what will be energy?
So 1D box or 2D box?
Oh, sorry, 2D box. Absolutely. Rectangular 2D box. Energy is scalar, people. So total energy, you can write E, nx, and y. Total energy, E, nx, and y. It will be simply energy along energy for x component. You can write nx plus energy for ny component directly. So this would be what? N square pi square x square upon 2 ml square. Be very careful. Have a look. N square pi square x square upon 2 ml square. Here also I can write n square pi square x square upon 2 ml square. But you have to write nx square. You have to write lx square. You have to write ny square. And you have to write ly square. Clear, people? Let me know if you have any questions. Very rarely, once in a blue moon, they might create a question of rectangular 2D. Mostly 2D box, when you say it means square box, people. Quantum numbers can still be different. Nx and y will still exist, but length, Lx and ny will be equal. By default, like the default 2D box, if they mention, you have to consider it's a square 2D box. Understand they have mentioned that it's rectangular, people. Default case, it's a square box. Lx and y you have to take equal. Nx and y can still be different, but Lx and y you can take them to be equal.
So sometimes they find and book a potential well that one. That is potential box, nothing else. Potential
Yes, yes. Well is nothing but a box, like unsymmetric well. That is nothing but a box, no? 1D box. Yes. Done, people. Let me know if you're writing. You can also take common in the energy. So what is energy? Nx, ny. It is, I can take pi square, x square upon 2m common. I'll be left with nx square upon lx square and ny square upon ly square. See, we have started with 2D. Well, let's see how much we're able to complete. But I will really want you to revise this whole multiplier come day after tomorrow, because obviously tomorrow we don't have a class. So please revise it down. Done. Next. Now you can learn 2D box. Like default case, unless they mention otherwise, you will assume it's a square box, people. You'll assume it's a square box. Lx will be equal to ly, and you can call it L. So in that case, people, the wave function sin nx and y, the wave function sin nx and y, that would be, what will happen? People, root of 2 by L, that will become 2 by L. And then you have sin nx by x by L, and you have sin ny by y by L. I hope you are ready. Look, sin nx by x by L, sin ny by y by L, root of 2 by L, that becomes just 2 by L. Clear? Any questions, anyone, anyway, so far? I hope you're finding this easy. And I've told you, just stick with theory. Numericals, you will find it easy, people. And as far as you're finding numericals easy, that's what we want at the end for geometries. And we're on the verge of completing quantum anyways. Verge is not verge, we have 4 lectures to go, but still. Okay?
Okay, sir.
What about energy? So energy nx, ny. It would be, again, Lx square, Ly square, they both will become L square, L square, no? Take L square common, people. So what we have? We will have pi square, x square upon 2 ml square. I'm just taking L square common. What will I be left with? In the bracket, we will have nx square plus ny square. That's why please mention about it. So nx and y are quantum numbers. Quantum numbers respectively along x and y axis. Nx and y are quantum numbers respectively along x and y axis. They cannot take value 0, same argument. Okay, people.
So that will be given in the question.
What will be given in the question? They have given. Oh, no, why will they give us? Like 3 5 case. So you know you have to start with ground state. We're coming to that. We'll form a beautiful table now. Okay. Achha. Now we are going to tell a let word here. Let n square be nx square plus ny square. But I need you to remember, I need you to note n has no significance. N is nothing here. N is not even a quantum number here. N is just something very random. N can be a fraction also here. N is just a random constant. It is not a quantum number. A random constant. We are writing it this way, just so that things look nice. Because what will happen to energy if you write it that way? Energy will become nx square plus ny square. That will become n square. Now that way your formula remains the same. N square pi square h square upon 2ml square. But this n is not your ground state first excited state. This is not that n people. It's a random constant. It's a random constant. It has no significance. No significance. You can write alpha also if you want. Right? You can write, let's say this is alpha square. Okay, so this is alpha square. Why are we writing n? So that by hearting becomes important. Like it becomes easy. What was energy of 1D box? N square pi square h square upon 2ml square. Now also it is n square pi square h square upon 2ml square. The difference is in 1D n was quantum number. It could take values 1, 2, 3, 4. But nx, this n is not quantum number. This n people here is nx square plus ny square. And nx and ny are quantum numbers here. I'm trying to hammer this in your head. I hope you're understanding this, people. In 1D box, n was quantum number. It was 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes on. Here n is not quantum number. Here n square is nx square plus ny square. And nx and ny are quantum numbers. Tell me one thing. Suppose if I would give nx is 1. Chalo. Suppose if I would give ny is 2. What will happen to n? N will be in root. Look at this n square, which is 1 square plus 2 square, which is 1 plus 4, which is 5. N is root 5. Like I said, n has no significance. And it's not a quantum number. Clear, people? It is just a random constant this time. Nx and ny are the quantum numbers, and it's not a quantum number. Write it clearly, please. Okay. Next. The time is less, and I don't know what to do. We can create a table. Let's try. How can I copy this? Next. So let's discuss. So obviously now you're thinking, but sir, then what would be ground state energy now? People, ground state would mean, suppose if I give you, it's a dice problem. I give you 2 dice, 1 dice and another dice. People, what would be the minimum possible combination if I give you 2 dice? What should be the minimum value you should get? 1 now. What is the next possibility in minimum world? Like you have to increase the numbers. After 1, what is the combination? 1, 2 or 2, 1. Correct. After that, so that is how we will decide. That is how we will decide what will be ground state. So understand how we will decide the levels after levels. Energy is proportional to n square. Okay, as you can clearly see, energy of nx, ny is proportional to n square. So it is proportional to nx square plus ny square. So depending upon the values of nx and ny, energy will increase. People. So for example, remember nx starts from 1. Don't forget. Remember ny starts from 1. Don't forget. So for ground state, people, what should be like we can start? Hang on, I'm also thinking. First, for ground state, what is the minimum combination here? Nx and ny, which is 1 and 1. Absolutely, nx is 1, ny is 1. Okay, but in that case, n square that you have, n square, that is actually nx square plus ny square. Okay, so that will be 1 square plus 1 square, which is 1 plus 1, which is 2. Which is 2. N square is 2. So your ground state energy, if you want to write, you can write E1 by the way. 1 will tell you it's ground. Okay, 1 will tell you it's ground. That the formula is what? N square pi square h square upon 2 ml square. So what will be it now? It will be 2 square. Sorry, no. N square is 2. N square value is 2. Okay, n square directly is, take care please. N square is 2. Pi square h square upon 2 ml square. So this is the ground state energy in 2D box, people. I hope you understood. Take your time. This is the ground state energy in 2D box. Pi square h square upon ml square. That's the ground state energy in 2D box.
Yes, sir.
Okay. Others writing, let me know. Next. So for first excited state, or you can say second level, what will be the next combination possible? 1, 2 or 2, 1. Both of them must give me the same value. That's obvious, people. So I can say the next possible combination is nx is 1 and ny is 2, or I can say ny is 1 and nx is 2. Both of them will give you same energy. Why? Because n square is what, people? Nx square plus ny square. Now, so people, if you write 1 square plus 2 square, answer will be 5. And if you write 2 square plus 1 square, answer will still be 5. So both of them are going to give the same energy. This is where the concept of degeneracy comes to. We have 2 different wave functions. Remember, you write nx and y. One wave function is 1, 2. Another wave function is 2, 1. But both have same energy. Both have same energy. Why both have same energy? Because n square is 5. And what is energy, people? Energy of the second state. This is second state, second level. Energy of the second state is n square pi square h square upon 2 ml square. What is n square, people? 5. Huh? So 5 pi square h square upon 2 ml square. N square is 5. Okay, n square is 5. So n square pi square h square upon 2 ml square. N square is 5 people. Both of them have same energy. So what it means? There could be simple 1 mark MCQ or 1 mark NLT. The degeneracy of the first excited state of a 2D box is, what is the answer? 2. Because there are two energy states which are sharing the same eigenvalue. Now you can write there are 2 wave functions which are sharing the same eigenvalue, same energy value. So degeneracy is 2. This is known as a two-fold degenerate. Two-fold degenerate. Degeneracy is 2. Degeneracy is 2. Because there are 2 wave functions which are sharing the same eigenvalue, which is 5 pi square h square upon 2 ml square. So people, after ground was just pi square h square upon ml square. Second is 5 pi square h square upon 2 ml square. Okay? And now important question. What do you think should be the second excited state? 1, 3, 1, 4, or 2, 2?
1,
2, 2.
2, 1 is already done.
2.
People, 1, 2, 2, 1 are already done. Okay, 2, 2 is the next combination. Why? Because listen, if you would take 1, 3, calculate n square. Yeah, it is 1 square plus 3 square. This is 10. Energy is 10 times because energy depends on n square. But if you take 2, 2, what is n square?
Yes,
2 square plus 2 square, that is 4 plus 4, which is 8. So this is how you have to decide. It becomes a bit complicated, but that's the fun of quantum. Now this will become more fun because this will become more mathematical. And if you enjoy mathematics, you are going to have fun a lot. Okay. So now you have to decide. You have to scratch your head. So now 1, 3 is not the next combination. Now 2, 2 is the next combination. So now you have to write second excited state or third level. Okay, it has to be nx will be 2, ny will be 2. That's it. So in that case, n square is what? Nx square plus ny square, which is 2 square plus 2 square, which is 4 plus 4, which is 8. Which is 8. Okay. And this does not have any degeneracy. Luckily, this does not have any degeneracy. Okay. So your energy would be n square pi square h square upon 2 ml square. The wave function is psi 2, only one wave function. Initially you had psi 1, 1, then you had psi 1, 2, 2, 1. There were 2 degeneracy, again non degeneracy. People, first was psi 1, 1, now no other degeneracy possible. first ground state, the ground state of first level, that's non-degenerate, right? If you want. The ground state was non-degenerate. The ground state was non-degenerate. The first excited state is two-fold degenerate. And third excited state, sorry, second excited state of third level, you can have E3 here. E3 means third level people. This is again non-degenerate. And that way you can keep on proceeding. You can talk about third excited state, fourth excited state, etc., etc., etc. Okay. Before we stop, I just want to take up one small question in this, and you need to tell me the answer here. Just one question. People, if I give you energy is 50 pi square h square upon 2 ml square, 2D box. I'm asking you, the degeneracy is. It's a reverse question. Energy is given, you have to guess the degeneracy. Pardon? I cannot hear. Too much of noise.
वन होगा सर, वन होगा.
Nah.
Non-degenerate.
Nah. That's
कौन सा combination possible है?
n square is 50, correct? है ना? N square means what equal n square plus ny square. That is
Sir,
50.
5 भी तो होगा.
That's what the equal combination has also. Hence I have taken this question.
7 1
7 1 and 1 7.
7
7 1 1 7 5 5 people. Okay.
3 होगा 3 होगा.
3. 5 5 is possibility because you get 25 plus 25. Then you have 1 plus 49 as a combination, and then you have 49 plus 1 as a combination people. All of them are 50. So 5 5 1 7 and 7 1. You have 3 degeneracy. I hope degeneracy का concept दिमाग में बैठा people. Thank you so
Yes,
much.
sir.
Please revise and come after tomorrow. Only then the lecture will go smoothly. Please revise and come. You may leave.
Mathematics है only.
Only mathematics, but that's the fun now. This is the fun part of it.
Yes, sir. अच्छा question.
Good.
Thank you, sir.
No problem.
Thank you, sir.
No problem.
धन्यवाद गुरुजी.
That has to.
Thank you, sir.
No problem.
Thank you, sir.
Thank you, sir.
No problem. Something in the chat box. Sir, time flies in your class. Thank you. Thank you so much. Chalo. I'll end the session.